Good morning, everyone, and welcome to day 2 of the COBOT Expo series Welding and Metal Fab event, and our first demo of the day with Matt from THG. They are going to be running us through some of their product demos. We will take questions along the way. Feel free to drop those in the chat box, and we will get to those at the end and get through as many of them as we can. So without further ado, Matt, the floor is yours.
Thanks, Jen. I appreciate it. And thanks everybody for joining us. Again, my name is Matt. My company is THG Automation. We offer a collaborative welding solution using the Universal Robots UR10E. We can use the 5E or the 16 as well. And we combine that with Fronius welding equipment. Fronius is world-class welding equipment manufacturer, and we implement the MIG welding packages with our system. We custom created the interface so that Fronius and UR work very well together. And our system is MIG only, MIG welding steel, MIG welding aluminum, MIG welding stainless, and many of the sub-alloys within those, as well as very thin materials with the cold metal transfer, to just thick materials with carbon steel. We have 3 packages. We have the basic package, which is a push system for pushing steel and stainless, and could push aluminum. And then we have a medium grade package, which is great for aluminum. And then of course you want to go to the highest end system, which is our CMT system, which can do all the processes that the other 2 can. So I'll take you to our interface, show you what we've set up and how our interface works, how easy it is to set up for yourself. And then we'll jump into maybe some teasers, some new stuff we've got coming that makes our system even easier to program than it already is. So here, I'll switch over and I'll show you what we've got. So this is our interface for the install screen. If you're familiar with Universal Robots, you've got your program screen and you've got your move screen, just as Universal Robots offers with their standard package and all the other capabilities. We have created in our interface the basic setups so that you can do metric or imperial units. If you see the little box there on to the left side, and then you set up the IP address for the Fronius. So if you have to change IP addresses for your network in your building, which you'll find that may be important if you got other equipment, that's no problem. Our interface allows us in the welding scope, and it allows us to set up our defaults. So all the defaults are your travel speeds, your corner path, your blend radiuses, your weld jobs, all this stuff is in these screens. So if you want to set something up, if you got a standard procedure, standard travel speed that you utilize, acceleration, whatnot, that's all set up right here. So when you create programs, these are plugged right into your nodes so that you can quickly implement your welding without going through each one and setting it manually. And then we've got this screen, which is for setting up your weld parameters, which in our implementation, we use Fronius's powerful job mode, which allows you to set up all your jobs in the Fronius and then your travel speed. So it's super simple to do. You don't have to deal with wire feed speeds and your arc length correction or voltage amperage, all that stuff on the UR interface. It's already in the Fronius. So yeah, that's how that's set up. So if we jump over, let's say we set up of weld parameters, we got a job 100 and we're moving at 12 millimeters a second, or about 25, 26 inches per minute. So we're going to go over into our program screen, and this offers all of the functionality that UR implements in their default software. And then of course our add-ons to that, which is all of our welding functionality. There's some extra stuff in here because this is a development system, so you won't. Some of the stuff would not be in our production units, at least yet. So yeah, this is our how you would get started with the welding, so the robot itself is set up with the torch. You've got the torch, which in this case is a push torch. You've got our interface between the robot and the torch, which is our piece that we added to make this thing work really well in the welding application. This allows us to take the robot and rotate it all the way around, so you're not impeded by the wrist. So you can go 360 degrees, no problem. And that way you can reach all the welds that you want to reach. The free drive button sets up here on the adapter, so it's easy to move around. It's got a nice grip, so it's easy for everybody to hold on to and move for long days of programming. We'll get into the interface here. In the interface, we have the basic moves and welds. And so on the top there's, we kind of create this so that from the top down is how you would start your process. So we're just going to add a move here in here. This move is ready to go with our defaults like we talked about. We have a linear move and we have a joint move. And for those that have programmed robots, you may know the difference between linear and joint. Basically, linear move, you'd move in tight spaces, or joint moves or more gross moves that would be faster for your weld process. We're going to leave it linear right now and leave all the defaults set up as it is. And then of course we have our blend radius, which we've left at 0. And that's this box right here. But you can change that, and that also allows you to go move faster when you're traveling between weld to weld. So basic process is, let's get this thing started. Let's set up a linear weld move, linear weld first. And so we're just going to start the robot about right here, and we'll hit create waypoint. So in this interface, we go to the standard Universal Robots move screen, and the move screen allows us to select the base of the robot for a coordinate system or the tool, just like you would do if you're doing something with material handling, or if you're, like in this case, welding. So you can move the robot up and down just as normal. And then, so in this case, we're going to press OK and allow us to seal that in that position. The next thing we would do is, well, add a weld start. So on the weld start, we've created a little bit of a wizard type scenario where the weld start and the weld end, as well as a weld process, is already set up. So you don't need the weld move P. We just add that so it makes it easier to put in additional lines of code, or you can go in and you can delete it. As well as, if you see when we change these screens, you get a graphical interface, a graphical representation of, let's say, a linear weld. So the red dot shows where the weld would start, and we'll move the robot down and simulate it. So we're going to weld here. So we'll put that right there, and we're going to create waypoint. Now, if you look, we've actually got, refresh the screen here. If you look at the interface, we now have 2 green dots. Beforehand, we just had 1 red dot where it shows the start and the approach on the bottom right. So what that did is it now tells us that we've already got that program, or that waypoint set, established somewhere. It may not be correct, but it is set. And even though our nodes on the left side of the screen are yellow. And there's another piece in here, which is called the approach. So what we've done is we've added a additional functionality, which allows you to set a approach position before the weld, and on the weld end, if we go over and set that point, then we now have a retract position. And both those approach and retract positions can be set from this set distance, the top number, which is 50. So right now, if the robot moves through these points, there'll be a 50 millimeter approach from the weld start and a 50 millimeter retract position from the weld end. That's great for if you want to do a bunch of strip welds on a long part and you didn't want to add a bunch of air moves in. You can set that to 10 or something like that. It comes up a little bit. and it moves over, and then it drops right back down to do the next weld. So it's a super sweet a feature that you can use it if you want, or you can take it out and just set that distance to 0. So, and we can also move to those positions. So it moves straight out. If you see the robot, it moved out away from the weld point in line with the tool center point of the torch. And the same thing will happen with our weld start. It'll just do a linear move to that start position. So we don't really need this linear move in the beginning, or we may only need one, and everything else will be covered with these approach positions and retract positions that are default. So I want to move to the weld move P. That's a standard process move in universal robots. What we can do here is we can set this position. So let's go over and just pop it down here in the middle. We don't really need it, but for demonstration purposes, we're going to put it in. And if we go to our move parameters, we can set all this stuff, like we can set an offset in case we're doing touch sensing, which we have multi-dimension touch sensing available, or we can set our blend radius, our weld job. So each move P, each time you add a line, you can change jobs while you're welding, which is really sweet if your material thicknesses change. The other thing we've done is we can change the type of move that we have in that node. So now, if you look at our screen, we now have a circular weld that now requires a via point and a 2 point. So now there's 2 positions that need to be programmed instead of 1, because we need to go from a point, through a point, and to a point to create an arc. So this is great for going around tubing or going on the outside of something that's circular, large radius corners on plate, or if you want to do a complete, like a weld fitting or weld bung, as they call it, to weld a complete 360-degree circle. So we'll show you that in a minute here, but we'll go ahead and put this back. And if you notice, the position that we programmed is still there. So it maintains that position in case we want to move to the circular move, and then it would ask us to actually put in additional position for that weld. So that's a really easy way for you to transition in your programs without having a bunch of additional nodes and the complexity in your programs. So yeah, so we can go to our start position real quick and watch. It could start here, and then we weld through it. So we're going to use our simulation button, which is here. Now this allows us, if we were to run this program, to simulate the weld instead of the robot welding. So all I'd have to do is let go of this button and the robot would start welding. Now, if you heard a click in the background, I'll tell you what that is here in a minute. So we're going to stop here. It's going to move out, and that's not an air move we added. That's just a retract point that was already there. So I'm going to take this, bring it up again, and I'm going to feed my wire out farther to where there's too much wire sticking out of the torch. Now we're going to go and we're going to set through our widgets. We're going to set this button here, which is called teach mode. And now, if I go down into the part with that wire sticking out too far, it should bend the part off, or bend the wire off. So let's try that again. So if you hear that clicking, what's happening is the Fronius power source and with the wire feeders actually pulling the wire back because it sees continuity and it's trying to protect that wire from getting bent, but it still keeps it into the joint. So when we pull back out, then it'll send that wire back out approximately where it was to start with. So it's a really great feature for you to be able to see exactly where that wire is going to be in your weld joint while you're teaching and not worry about it being broken off. So that's a really cool feature. We're going to shut that back off so that we're not listening to the fan run. So With our system, we also have touch sensing, where if you come in, you want to add a touch sense to see if a part is moving back and forth. So let's say this part moves a little bit back and forth because of part variation or just because of warping or whatnot. We have touch sensing that we can apply to this process so that we can move the weld back and forth based on the position of the part and adjust for those movements. We also have seam tracking. So seam tracking is really easy to use as well. So when you go into your, let's say the move P and you want to start weaving, you'll see your weave parameters here. You'll notice we have the standard weave. You can weave at 90 degrees, which is side to side, or you can go to 0 degrees, which would be back and forth, or any variation of that. You've got your weave width, the weave pitch, and we've also added dwell left and dwell right for doing stainless and other, dissimilar metal thicknesses from one piece to the other, so you can concentrate your heat. The one other thing that we've added that makes it really simple is once you've got the weave established, you see the little box that's being turned on and off on the right side, that's seam tracking. So what seam tracking does is it utilizes the weave and allows us to automatically realign the weld path with the part. So if we're doing an inside corner weld, for instance, like in this case, and the robot is running along this path, then if we have the weave turned on, then that weave will allow us to see the part variation. And with seam tracking turned on, it'll actually readjust for that part. So once we use our touch sensing to find the beginning of the weld, then the seam tracking will take over and allow us to find that part all the way to the end. So again, very simple, very quick to set up. We've got other features like part check. You can check to see if a part is there or not, to swear if you don't want to weld your tooling and destroy your tooling with a part not being present, you can use that. That's simple to use. The one thing I'm going to go to next, a lot of this stuff is standard, more advanced features for like heavy welding and such, and we can show you more about that on our website. The one feature I wanted to jump into that we're going to release here soon is in our installation. And this feature allows you to pick the material that you're going to use and the gas you're going to use and the wire, and it will automatically set up your weld job and your travel speed for you. So let's say if you're not really familiar with the Fronius power source in the beginning, or if you're not quite sure where to start, we've now added this functionality. So this screen would normally be used to set up your weld job default and your travel speed default, so that when you set up your jobs, then you would go in and start, it would propagate your weld parameters automatically with those defaults. What this does is we hit the checkbox. Now it opens up this new functionality. So let's say we use filler wire. In this case, we're using ER70S6, and our wire diameter is 45 thousandths. We can keep adding new functionality as we go along. And then let's say our gas, we're running, in this case, I think we're running 10%. And then we want to add our material thickness. So at the top, you'll notice that we were at a weld job of 100 and a travel speed of 10. Now we're setting at a job of 113 and a travel speed at 10. So if we clear this out and we start over, let's say we want to run stainless in this case. And let's say we're running 45 thousandths wire, which is the option we've added in for the moment. And we want to run 2 to 5% CO2. Now we pick a material thickness again. Let's say we're running something really thin, 16 gauge. Now our job is 101 at 18 inches a minute. We can keep going. We can say, hey, let's pick a different gas. Let's go pick carbon steel again. In any direction you want to go with this. So now we're running job 123 and a travel speed of 6 millimeters per second. So as you can see, this is really simple to add your weld jobs in, or to actually just select a weld job that's already established in the Fronius and your travel speed, and gives you a baseline to where to start. Now I'll show you something else that makes this even more powerful and yet really easy to use. We're going to jump over to the Fronius itself. And if you see here on the left side, this is a web browser with the Fronius interface. So what we're doing here is, we can see all my links here. I didn't clean that up. So we've got, these are the jobs that are setting the Fronius right now. But what we can do is, let's say we want to add a new job. We can either use the job we have, and we can save it as, or we can go in and we can pick a job we've already got, save as. Yeah, so we can pick a new job. So let's go with the new job. We can pick one of the 1,000 free job locations. If there's nothing there, you can add something in that spot, and it says free. And let's call this new Expo job. And then we can pick all these different materials. In this case, this is what's available. This list can grow as the options in the power source grow. So let's say we want to run stainless. We can run multiple different wire thicknesses or wire diameters. And then we can pick multiple gases, including helium mixes, tri-mixes. So we'll just stick with our 2 to 5% right now. And then all the different processes that Fronius offers. You can leave this all universal. You don't have to get crazy on this. But if you're wanting to do something really special and you're just not getting what you need with standard MIG pulse, you can do PMC. You can jump into like a mix, which jumps between a PMC pulse mix and short circuit. So it lowers your input temperature, but it keeps your spatter down still. So we've got all these different options we can add, and with between ourselves and Fronius, we can definitely educate you on all these different processes when you're ready. But in this case, you could just keep it simple, leave it as just standard MIG pulse, and press go. Now, the Fronius interface gives you all these different settings that you can use to adjust your welds, but you don't need to do anything with that stuff. You only need to do one thing, and that is change, let's say, our wire feed speed. Let's say we go to 350. When we go to 350, it says our material thickness that we can weld right here. And it doesn't see my cursor here, but if you go down to material thickness, it shows we're at 0.145 inches of thickness, but in gray, it shows 0.39. So if we hit save adjustments, now it tells us what our material thickness is about halfway down. And that gives us an idea of what material thickness we would be welding with those parameters. Now, it doesn't give us our travel speed, but that's why if you need to know that, you can go back and use the interface for that we've set up for your preset. So when we ship these systems, these jobs will already be set up. So there'll be a long list of jobs in this list on the left side. And you can leave those alone, you can use them, or you can go in and let's say we want to save a job that we like that was already in the preset list. We can just hit save as, pick a new location, go anywhere you want, up to 1,000 jobs, and hit the job you want to make it and rename it and press OK. So now we've got a new job that is a copy of a job we really like, but we want to modify it. So let's say you go into our preset screen in the Universal Robots interface that we've created, and you pick the material you want and all the parameters you're using here you like, and you want to start playing around with this. You can use this job and go back over into the Fronius web browser, and you can adjust those parameters by creating a new copy of it. So it's really slick. This is definitely a way of leveraging the technology that Fronius, the Universal Robots, offers, and allows us to do things that we wouldn't normally be able to do with traditional industrial systems. So with that said, Jen, I'll send it back over to you, and if anybody's got any questions.
Perfect. Okay, thanks, Matt. Anyone out there that does have any additional questions, feel free to drop those in the chat. But we will get started with the couple that we've had come in. The first one here, Matt, if there are software updates, are those available to a customer?
Yes, they are. So we offer a year of free updates to anybody that buys our system. So as we add new weld jobs to the list that I just showed you in this new feature, we'll give them the new file for that, and it'll constantly propagate into more jobs. And remember, we can do carbon steel, stainless steel, aluminum, and all the different processes. So as we continue to develop these new materials and processes, we'll expand this. We'll start out with just steel though. And then of course, all the features we add into the robot itself, that'll also be available for free up to a year.
Perfect. Matt, what UR cobot model are you typically using in these situations?
The UR10E has actually got the best reach for that 10 kilogram payload. So that's the one we typically sell. We have had requests to use the 5s, and we can also do that as well. It's the same interface on the end of the robot, the tool face. So we can use the 5, the UR5E, obviously UR10E, and then the 16E if they want.
Perfect. What does support from THG Automation look like?
Yeah, so that's a kind of a 3-tiered approach. When a customer buys our system, we buy that robot for the system from their local distributor. So wherever in the country, Universal Robots' world covers the entire planet almost. So whatever distributor in the United States that our customers are close to, we'll buy the robot from them. They'll be able to give them support initially before the robot shows up, get them prepped with safety features, with how to use the robot in general. And then when we ship the system or deliver the system, we will give them either virtual support if they want. Depends on whether they have our system or not, and they're familiar with Fronius. Some customers don't need that. Some customers need full help. We'll stick around for a day for free and help them get started with our system and training, and then additional phone calls if they need. And then finally with Fronius will come in and help them understand the power source better, consumables, where to buy that, and any additional questions they have as they get used to the power source if they've never used Fronius before. So.
Perfect. What if someone already has a UR10E? Can they buy just the welding package from you guys?
Yeah, they can. Just we'll quote the system without the robot, and then they'll just ship the robot to us, and we'll install it. We have had situations where the customer can install it themselves, so we'll ship it without the robot, and then they just put our UR cap on their robot and finish mounting it to the base. So however they do it, it's pretty quick and easy.
Perfect. A little bit more of a technical question for you. What is the limitation of seam tracking?
Right now, seam tracking works with carbon steel, stainless, and we're working on aluminum. So it does work with aluminum as far as the signals are concerned, but we haven't really got it ironed out yet. But it will work on the linear moves, and it does work on the circular moves. So if you're welding a fitting or something and the fitting is moving around a little bit on you, just turn it on and it'll find that fitting for you. It is limited because you have to worry about the torch angle as well, but if it's moving around enough to where the weld doesn't succeed, but you're close, then just turn seam tracking on. It'll find a circular weld as well.
Perfect. All right, well, we are down to the last minute, and I want to talk really quickly about your keynote. The THG Automation keynote does go live today at 11 a.m. Eastern, so here in about 30 minutes. You can find that in the auditorium of the virtual event. And that session with Matt is titled Ways to Rethink Your Welding Production Team with Automation. So be sure to check that out. Be sure to stop by the THG booth as well. Look at all the great content they've got loaded up for you in there. Matt, any closing words before we wrap up?
No, we appreciate being able to do this. And anybody has any questions, contact us directly. And we can run your parts here, demo virtually or demo live to see if our solution meets your needs.
Perfect. All right. Well, thank you, Matt, for a great demo. And thank you, everyone, for tuning in. We hope you enjoy the rest of the event.